All right, so that was the theory. Now let's apply it. And a lot of you have also had troubles with piecewise functions. Again, forgive my poor spelling, but let's use a piecewise function as an example for our limits. Let's say cosine of 2x, let's say x squared, and let's say 1 over x minus 3. Let's say this is x is greater than 3, this is x less than or equal to 3, less than or equal to 0, and let's say these are all x values less than x, or x values less than 0. There we go. All right. Now let's say the problem says, hey, is it continuous at x equals 3? Well, as x approaches 3 of limit of f of x, if it were continuous, it'd have to exist. But that's our problem. We have to figure it out. So like I said earlier, we just find the left, we find the right, and if it's the same, kawabunga, you're all good to go. If it's not, we move on. So the limit as x approaches 3 from the right, well, what are the numbers to the right of 3? Well, we have 1 over x minus 3. And then, is that equal to the limit as x approaches 3 from the left? Well, what's our function to the left of 3? X squared. Well, now let's walk through the line. So 3 minus 3, that's 1 over 0, and we can't simplify it, we can't take the conjugate, we can't factor, there's nothing going on. But look, numbers greater than 3, or 4, or whatever, so this bottom piece is always going to be positive, so that gives infinity. And this, well, that's just you plug in 3, you get 9. Is that equal? No. And you're done. Usually you'd be lucky if they give you a function like this, and they give you intervals. Most of the time they may give you a picture, like, oh, here's something like this, maybe it stops there, and then they do kind of like a this thing, or they do one of these, they stop it there, and then they go up here and they go crazy. So they ask you, like, what are these random limits? And you'll just have to compare. Like, oh, so the limit here doesn't exist. It wouldn't exist here. It wouldn't exist here. But let's do one of these. Why wouldn't it exist? Because the left and the right aren't the same. But what about this one? Would this one exist? That's my question for you. Now we see that there's no value there. So let's say this was, I don't know, my favorite number, 5. F of 5. Does that exist? Oh God, no. But since when does a limit ever care if a value exists? No. We just want to know if we're approaching something. If the left and the right are approaching the same value. So let's look at the left values. If we kind of follow this line, we'll see it's approaching, I don't know, let's make that 12. We'll see it's approaching 12, the left numbers. The right numbers, we'll see it's also approaching 12. So we say that the limit as x approaches 5 of our function is equal to 12. Now again, that value doesn't exist. Even if it did, even if it was up here, that wouldn't matter because we are approaching that same value, and that's all that matters for a limit. Keep that in mind.